Hello everyone. Welcome to this session, Open Networking with Arista. My name is Surya Narayanan. I work on the Cloud Systems Engineering team at Arista. While I support my cloud customers, I also lead platforms and solutions co-development efforts for my customers. Along with me today is Ryan Torres.
Hello.
Ryan is part of the software engineering team and wears multiple hats. He runs the software engineering team and also leads Arista's efforts to support open solutions and co-development efforts for our customers. Before we get started, let me address some logistics. We would love to hear from you during today's presentation. If you have a question for us, feel free to send it during the Q&A chat. If we don't get to your questions, please do reach out to us via email. Our contact info is here on the slide. So let's get started. Why are we here today? Arista has a long history of collaboration and openness. We'll recap how Arista has introduced open solutions to our customers over the years. As we have pushed the bar, we have also co-developed open hardware and software, deployed and supported them at scale, even hyperscale in some cases. During this process, we have learned a lot, and we will share our learnings and experiences. We'll walk through our experience of driving the Maxsec project. Next, it's our general observation that companies that have large networks and resources manage to adopt and implement open solutions. However, smaller companies tend to struggle. We want to make it easier for everyone to adopt open solutions. To that end, we will share our next steps in continuing to contribute and support the open community. Arista was founded in 2004. Instead of adopting proprietary silicons, Arista adopted merchant silicon and Ethernet from the get-go. On the software front, Arista built EOS, a modular operating system with a unique state-sharing architecture on top of unmodified Linux kernel. In 2008, Arista had their first stint of platform collaboration. In 2010, Arista enabled support for third-party software on EOS. In 2013, Arista released support for SDK. SDK allows users to build custom applications and programs that work seamlessly with Arista platform and EOS. In 2014, Arista released eAPI. eAPI allows applications and scripts to have a complete programmatic control over EOS. While Arista has continued to work with standards-based technology, the last few years, since 2016, Arista has spent significant time collaborating with OCP solutions. In 2016, Arista enabled Sonic on Arista hardware. At first, it was one silicon family and one device. In the last few years, we have expanded Sonic support on multiple silicon families and multiple devices. In 2017, Arista enabled support for EOS on OCP hardware, Facebook Wedge 100. Similarly, Arista has also enabled support for EOS on multiple white boxes. Last year, at the Global OCP Summit, Facebook announced their new 16-plane fabric architecture, F16. A new switch with certain physical, mechanical, and thermal specifications was necessary to support this architecture. Arista embarked on a joint development program with Facebook to build a switch for this new architecture. Both teams worked parallelly. While the Facebook team built MiniPack, the Arista team built Arista 7368. The Arista 7368 is a high-performance system that enables up to 128 ports of 100 gig or 32 ports of 400 gig. The Arista 7368 is built on a single Tomahawk 3 chip in an extremely compact 4RU form factor and provides flexible configuration and choice of interface module cards. On the software front, 7368 runs the same Arista EOS software as all other Arista products. The Arista 7368 also supports FBOSS. We're also working to enable Sonic on the 7368. 7368 is a fantastic example to showcase the concept of openness and disaggregation. It enabled Facebook to deploy in multiple tiers in the F16 architecture, and at the same time also provided them the choice of network operating system, EOS and FBOSS. As you can see, we have come a long way. In 2016, Arista submitted one file on GitHub and got Sonic running on Arista hardware. Not too many features back then. Fast forward to 2020, Arista is deployed at scale With EOS, FBOSS, and Sonic, it's the same Arista hardware, but the choice of operating system is based on features and other operational requirements. It's a general myth that cloud companies deploy white boxes to save on cost. The main reason is integration and control of stack. Through joint development projects and other efforts, Arista has provided high-quality software and hardware solutions to these customers. Arista has helped address challenges with time to market for new products and mitigate risk in execution and supply chain, in turn providing an amazing operator experience. Our development efforts with customers are more intimate than ever before. It's an engineer-to-engineer collaboration right from the design phase through production support. During this journey, we have run into a few challenges with co-development. To share more, I'm going to pass on the mic to my colleague, Ryan. Ryan, take it away.
Thank you, Narayanan. I want to share the story of how we managed to use Facebook's driver code for FBOSS onto Sonic, and how we took the insights we learned there to solve security projects for co-development by defining the SAI Maxsec specification. Last year, aside from delivering the 7368 Tomahawk 3 modular system with EOS and FBOSS support, we also released support for a Jericho 2 fixed system, the 7280 CR3 platform with EOS and Sonic. On both products, the Credo Babbage Asic is on the data path. The Credo Babbage gearbox, also known as a PHY or physical layer chip, converts 50 gig PAM4 to 2x25 gig NRZ so that we could expand 2 lanes of 50 gig into 4 lanes of 25 gig to form a 100 gig port. Facebook drove the full implementation of the FBOSS Babbage software, getting guidance from Credo on the SDK and register definition, and know-how from Arista to connect the OS to the hardware access of the chip. In addition, because Arista was developing EOS in parallel, Arista's system-level understanding and mature automated testing allowed us to jointly overcome the hard bring-up bugs along the way. Our collaboration with Facebook and Credo included organizing war rooms when our bug queue was piling up. On the right, we have a team of engineers from all 3 companies figuring out why the links were not coming up. And that's me taking a photo of an empty whiteboard. EOS does not use Facebook's implementation of the Babbage drivers due to differing feature requirements. However, to ensure software quality of Facebook's Babbage software on Arista hardware, we incorporated their implementation into an internal EOS build and validated register values in link state. In order to get FBOSS PHY software to run on Arista hardware in an EOS environment, we received regular code drops from Facebook and put hooks for the software to work with EOS architecture. The tests continue to run in Arista automated test environments today. Meanwhile, the Jericho 2 box Sonic work was also ongoing. Arista leveraged the same Credo Babbage ASIC also on the 7280 R3. As we were trying to scope out the work to get links to come up on the 7280 R3, one of our engineers joked that we should just use Facebook's FBOSS Babbage agent on Sonic. We took a risk and presented this idea to Facebook, Microsoft, and Credo. And to our surprise, they all supported the reuse of Facebook code in Microsoft Sonic. So now, Sonic on 7280 uses the FBOSS Babbage driver. After all, why not reuse the code? At OCP in March last year, we attended a Sonic community talk and realized that external data plane chips, like the Babbage gearbox or Maxsec chips, for example, are a general gap in the open ecosystem. As Guohan from Microsoft was explaining on the right, there is no standard programming interface so that an operating system developer can easily onboard a new external chip vendor because we spend so much time customizing the code to each vendor's SDK. At this point, we felt encouraged to get involved in the development of this common API layer for operating systems to manage different chips. The criteria we evaluated were: Arista has a unique perspective of the software area, EOS can have future benefit, and we can influence the direction in order to improve software quality and customer experience in co-development projects. As we learned in the Babbage project, code reuse is top of mind. We considered driving the Phi area, but we knew that many companies would jump on this opportunity already. Arista, on the other hand, has a very large install base of Maxsec-capable systems. We have seen the most common use cases in real deployments, and we see Maxsec moving from a specialized feature in some products to becoming a more necessary native feature for secure connectivity. To those of you who have not interacted with Maxsec before, let me spend a minute describing it. There are two switches in two different buildings connected through some fiber. Important information, such as an individual's social security number, gets transmitted with an unsecure connection from one building to the other via these two switches. Now, a malicious person decides to snoop into the traffic in between the two buildings by getting a replication of the traffic. Now this person can see the social security number of the victim. This is not good. For this kind of application, the operator can enable Maxsec on both sides of the connection. The data gets encrypted on the way out of the first switch and securely decrypted when it reaches the next building. The malicious person's plan has been foiled. Basically, Maxsec is L2 encryption. From a physical standpoint, an external chip can implement encryption or decryption logic, or it could be done as part of a forwarding ASIC pipeline. The simplest implementation is point-to-point encryption, like what I showed you in the previous slides. We decided to drive the implementation of the SAI Maxsec to define this new API layer. We'd like to share experience on the logistics of adding a new specification. All in all, the SAI Maxsec standard took 6 months to complete the first phase, which is merging the specification onto the SAI repository. We worked with a group of network operators, ASIC vendors, and system developers. Facebook organized the meetup, and we spent a day in person and multiple weeks of calls to close on the specification. We had a private drive and a mailing list to share progress. Now that the specification is open source, our observation is that community members evolve the specification over time. Emails happen between ASIC vendor and author, between cloud network operator and author, but anybody is able to evolve the specification. The Thursday 8 a.m. calls are where the community reviews and finalizes any open requests. Now is the phase when we are seeing this get into actual business opportunities at various companies. There is a tight cooperation between the system vendors, the ASIC vendors, the cloud network operators, and the SAI spec authors to align on feature improvements and other related topics. To share some final thoughts about our experience, I'd like to talk about maintainership and adoption. When we were asked to explore using ACL-like semantics for defining Maxsec rules, we tried to find the right person in the community to ask about some definitions. Looking up the author of the area we were interested in, we came across contacts that were unreachable. The weekly SAI community meeting provided the avenue to ask the questions because all the experts were there. There was a healthy set of reviewers from the NOS side and also from the other vendors. Just as the Linux community has package levels maintainership, EOS has package owners. It would be great if there were an up-to-date list of owners of the different headers in SAI. What we are seeing is that OS developers, including Arista EOS, are trying out implementing portions of the spec. The impressive thing is that we see the chip vendors that we are interested in all having a roadmap to SAI, which makes it more compelling for EOS if it enables a faster time to market of a new ASIC. The spec will need to continue evolving to meet features of the OS, including performance, to get adoption. We're looking forward to getting Maxsec SAI available and successfully deployed in our upcoming development project. Now I want to turn to an important consideration in choosing open software, the software that manages the forwarding ASIC. I hope that this section gives you an additional perspective in selecting the software stack for your hardware as I introduce Arista SAI. Network ASICs are hard. Getting the basic features to work is one thing. In our estimates, It takes tens of person years to develop software for a brand new ASIC, 3 person years for a chip where we leverage the majority of existing work, and also tens of person years for major generational changes within the same ASIC family. The dimensions of interactions and maintaining long-term software quality in every release, all within a single image, add to the complexity and cost of the software. Some of the big challenges are interaction between features, meeting benchmarks, the ability to debug via counters, logs, cookies, and canaries, all the custom knobs in each feature, recovering features in the face of inevitable software bugs, changing speeds dynamically, card hot swap and multi-chip ASIC management on modular systems, hitless system upgrade, supporting the variety of hardware platforms and fitting every kind of front panel speed or media type for a given ASIC, selecting the right default behaviors. For example, how to behave when handling parity errors. And finally, long-term support, as a single software stack needs to support the lifecycle of the ASIC. In the open ecosystem, the Switch Abstraction Interface, or SAI, is becoming a common standard to manage network ASICs. It provides a software contract between ASIC management and the network operating system. In the example of the Sonic Open Operating System, the OS developer makes calls to SAI, and the SAI implementation is usually done by the ASIC vendor. From a high level, operations on SAI objects become reads and writes to ASIC registers. The existing software offerings by ASIC vendors are in a single process. Arista EOS's way of managing the complexity of software ASICs is the use of a multi-process architecture. There are 2 concepts that we use: slice agents and feature agents. Each agent is one separate restartable Linux process. Slice agents use the vendor-provided SDK and are instantiated per chip. For the most part, the slice agents only do chip initialization and manage a subset of the tables that change less often. Feature agents manage a single feature and perform direct register accesses to the ASIC tables related to that feature. A given feature agent has ownership of the tables within the ASIC that it manages. Feature agents gain efficiency by managing all ASICs in a multi-chip system at once. Examples of feature agents are the ASIC L2 agent, L3 unicast and multicast agents, the mirroring agent, etc. On the diagram, the database provides the contract among all the different slice and feature agents. There are many benefits to this approach. The code for each slice and feature agent gets tested across many ASIC generations and families. We get the ability to create agent and package maintainer teams for sub-areas, and maintainership and ownership is clear. Testing is done on a per-process basis, and each process is fully restartable and recoverable, making hot fixes and resiliency to bugs easier to handle. In addition, agent evolution is determined by the area specialists, for as long as contracts are made in the database. It scales with modular systems, debug logs are available per agent, traces can be turned on per agent. There are fewer dependencies on SDK bugs, since feature agents bypass the SDK and go straight to the table. Finally, bugs and crashes are restricted to a single process. In fact, features are designed to self-heal after a process restart. I believe this architecture allowed us to evolve from supporting one ASIC with a small set of features to supporting multiple ASIC generations and families and maintain high software quality. I'm happy to share the new Arista SAI. Arista SAI packages our multi-process ASIC management software into Sonic. This new offering is an alternative to an ASIC vendor's SAI implementation on Sonic. Arista SAI allows a customer to choose an open software stack and benefit from Arista's ASIC management software. Sophisticated customers can focus on protocols, applications, and management systems, and trust that the ASIC management software is supported by the Arista team. There are 2 parts to Arista SAI and Sonic. Syncd Arista is a container that runs Arista SCI state logger. It takes SCI calls from Sonic and serves and listens to messages to and from Asic Arista containers SCI interface agent. Asic Arista is a container with Arista Switch Asic Manager, Arista's multi-process ASIC management software that translates SCI calls into hardware writes. Arista SCI is a transparent alternative to an ASIC vendor's SCI implementation in the Sonic operating system on selected hardware.
Thank you, Ryan, for sharing your insights on joint development, SCI Maxsec, and Arista's SCI architecture. With Arista SCI, operators have a choice for the software that manages the forwarding ASIC in their switches. So, which ASIC management software is right for you? The answer depends on a few things. If the operator has a sophisticated engineering team dedicated for their network and want to use fully open source tools or be willing to write software as needed and are a large cloud titan or only use the same features as a large cloud titan, then they could use the SCI provided by the silicon vendor. In this case, operators will have to work with the community to debug and resolve problems, even for critical packet forwarding functions of their switch. On the other hand, if the operator wants to benefit from Arista's proven and resilient platform software that uses slice and feature agents for ASIC management, as well as take advantage of Arista's global tax support, Arista SCI powered by Sonic is a fantastic choice. Operators get the best of both worlds with this approach. And the beauty of this is operators can use the same Arista hardware, deploy Sonic with vendor SCI or Arista SCI, or even deploy EOS. The flexibility with open hardware and open software with complete tax support provides the operators the confidence to deploy open solutions. Call to action: get SCI Maxsec deployed. And to do that, ASIC vendors start implementing your SCI stack. NOS developers build your Maxsec software stack. And operators modify your provisioning systems to start using Maxsec. If anyone is interested in a specific feature or has use cases, do reach out to the working group via scimaxsec@arista.com. The latest specifications can be accessed via the project page on opencompute.org. Next thing to think about is software quality. Think and invest in software quality as you build more features or scale them, whether this is for your tools, control plane, or platform software. This has been one of the biggest strengths for Arista and has also helped operators deploy and scale at a rapid pace. Thank you for taking time and attending our session today. We hope this was useful and look forward to hearing from you all. Thank you.
Hey guys, thank you for attending this session live. Feel free to post some of whatever questions you have in the Q&A window or in the chat window, and we'll try to answer this question live. Ryan, do you want to answer Arkadiy's question first?
Sounds good. Hi, everybody. Thank you for joining us here. The question from Arkady is about if Arista SCI is not embedding the entire EOS and it's just for ASIC management. The answer is yes. Basically, as far as we've seen in Sonic, it is one option is to have containerize the whole EOS and manage significant portions of the stack. But I think the observation we're making here is that the ASIC portion is a critical portion of the operating system, and we have had a lot of experience in packaging our software to be able to manage different kinds of ASICs in one software stack. So what we are doing is, with Arista SCI, is to repackage just the portions of EOS that manage the ASIC and make it fit into the Sonic OS just for the ASIC management portion.
Thanks, Ryan. Folks online, if you have any questions, feel free to post it. We are going to stick around here until 10:30 Pacific Standard Time.
Yeah, just for folks, the question that came from Abhiram was, from the networking software OCP contributions, is Arista only restricted to SONiC and FBOSS? And the answer is we do kind of focus on SONiC and FBOSS, and with ONL with FigSwitch. On top of that, we've participated sort of in the open source world and in sort of open standards for a long time, dating back to when we were founded. Rahul is asking, how about other entities like platform management and other protocol containers? Sounds good. So a few years ago, you will have seen us show the Arista container for the Arista routing stack. So we have showed our ability to do that. As far as platform management goes, we have open source drivers to manage a significant number of SKUs, sort of in the Broadcom and Intel Asic families, to allow SONiC to boot up. So platform management would be done using those open source drivers that we've already contributed. Arkady is asking a clarification. Does this mean Arista is just supporting ASIC management, or the customer can file support cases with Arista for any portions of SONiC running on Arista platforms? I'm more familiar with sort of the technical changes we're making. Do you want to comment on this, Narayanan?
Yes. So that's a good question. The goal here is to provide amazing operator experience. So while customers would run SONiC on an Arista platform and file for support cases, the Arista global stack is a world-class stack, and they will end up supporting from an Arista hardware perspective and from an ASIC management perspective. When it comes to the SONiC portion of the code or SONiC portions, if something has to be troubleshooted, they will try to help out, but that will be best effort. At the end, we want to help the customer, and we'll try to point in the right direction. But if we need to address something that we don't have control on, and it's in the open source community, we'll try to point them towards the right direction. So we'll try to help and do our best, but our goal will be try to address whatever is from an Arista platform perspective or wherever the Arista SI component comes into play.
All right, the next question from Rahul. Do they have EOS components to it, or are they native SONiC? What are you referring to as they? Are you talking about the platform management? If that's what you're talking about, then that's right. So for SONiC, the platform components are separate from the EOS source code base. There are overlaps, but we use the open source version for SONiC for managing the platform. Thank you for your question.
Again, to add some color, the reason why we are doing this is we want to provide, all the flexibility for all the operators. And in this case, hardware is one component, and then folks try to divide software as the other component. But within software, again, this is where Arista can bring in value, and we want to provide all the good work that we have done over the years for platform software. But at the same time, if customers want to run or operators want to run SONiC, they still have the ability to run SONiC, but get all the benefits of the platform software. In addition, we have had customers wanting to run Arista's certain portions of the code, something like BGP or our routing code on top of SONiC. And that we have done a few years back. So something like running CEOS, which is containerized EOS, on top of SONiC for all the platform independent portion of the code, you still run SONiC because you want to maintain a standard operating system across your fleet or across several places. And then you have Arista SI at the platform layer, and then again, an Arista platform, finally. The biggest advantage here is for folks who are just starting out and want to try out whether SONiC is the right path, but are not fully confident. Get started with an Arista platform. You can use EOS as always a fallback option, or the go-to option, and then try out SONiC. So there is a lot of investment protection here by going down this approach. And then finally, providing tax support also helps. We believe this should help medium to large enterprises and smaller customers take on SONiC as the future. And we are just trying to help out the folks adopt the open solutions.
All right, I think we are 30 seconds away from overlapping with the next talk. Thank you so much, everybody, for attending. I hope that you found this informative. Please feel free to contact us. We'll be around for the next few days in the conference, meeting some of you in the virtual coffee room. Thank you very much.
Thank you, guys.